Okay, so welcome to the community sync. So I'll just quickly summarize some of the highlights in the last couple of weeks. We had a lot of activity on our blog. We published a Blob V2 deep dive. So Lance Blob version 2 is out. It's in the format right now. I believe it's not yet fully migrated to LanceDB, but that's on the way. And then we have the benchmark blog post as well on the 2.2 file format. It shows some really good improvements in performance as well as compression compared to both the version 2.0 and Parquet. And then just earlier today, we published a blog post on variants versus JSON-B, or binary JSON. And yeah, this shows some good performance numbers as well. We have some tables showcasing how it performs against the Parquet variant type. Yep. Oh, great. Yeah. This is awesome work by both Shonwo and Jack. A lot of benchmarking as well as a lot of performance improvements in the last couple of weeks. And then we also published a guide on how to upload Lance datasets to Hugging Face Hub. So if you haven't checked that out, it's on the blog as well. And then there was a lot of commits in the last couple of weeks on bug fixes. Many of them from community members as well as members of the Lance team. So many thanks to all the community contributors who've been both patching bugs as well as adding optimizations. A couple of improvements on IVF as well, a lot of indexing improvements. So you can go through the commit history on the latest release of the Lance SDK, and you'll find out a lot more information in these PRs. So I think we can go over some of the topics related to the upcoming release now. I believe 4.0 SDK came out recently, so we can start with this topic.
I don't know if we have any plans for a patch release, but I guess one question I have related to that, like the one bug that stood out to me that might be worth patching is the multi-part upload bug, but I'm not sure if that's something that was in the 4.0 release or not.
Which bug?
This one here.
Oh.
So it looks like yeah, it's been fixed and merged via a PR, but last week.
Yeah, I know it was fixed, but my main concern is, was it in the 4.0 release, or was that bug introduced in a beta release?
Well, it was in a beta release only. It was never in a release.
Cool.
Okay, so that leads to the question. Yeah. So would that be a minor patch release, Will? Like, is that the question here?
Yeah, well, my question is, do we have any bugs that are bad enough that make us motivated to make a patch release?
Yeah, if that was in 4.0, I agree. We would definitely need a patch release. But I checked into that. It was introduced in like beta 3, I think.
So then I think we probably would just go ahead and start with the RC on 5.0 next.
I think Jean just created the 5.0 RC1, the release branch right now. So.
Okay.
So does that cover all the things we need to talk about 5.0 as well? I mean, is there anything specific anyone wants to bring up regarding features?
I don't think so.
Okay. Cool. So we can start the discussions then. I think the first 3 are on you, Will.
Yeah, I think we might have brought up last time a bit. Someone mentioned a bit about having better issues for or better labels for triaging issues. I was contemplating like proposing having potentially 3 labels: one for needing more info, doesn't like we need to sort of gather more information before someone's ready to work on it, and then 2 And 3, one would be like ready for an agent to work on, ready for a human to work on. Agent 1 might be sort of more like it's sort of self-contained enough that we feel like you could sort of one-shot it, versus ready for a human, or sort of marks that it really needs human attention to be able to get it to completion. I'm curious if we think that those would be helpful labels.
Repeat what the labels you were thinking about were? Sorry.
Yeah.
Yeah, the first one would be needs info, which is just like the issue doesn't have enough information to start working on it. You know, maybe you sort of discuss what's in scope and what's not in scope, or what the problem you're actually solving is, or so that sort of thing. And that just like helps you identify which ones you need to sort of work on more. And then there's 2 ones that are sort of say that they're ready to work on, but one's specifically saying like, hey, this you could assign this to an agent and probably one-shot it based on the information there. And then the other is like, oh, you should probably have like a person in the loop to really figure this out, because it's more complex or requires more judgment. I think this one in part is like it could sort of stand on its own as it might be nice just to have a label that helps us say like, hey, like, please don't start on this yet. Like, we need to talk about it first, versus like, this is ready to go.
Yeah, I think needs info is a polite way of saying like, I'm not sure I want this at the moment.
Yeah.
For the ready to agent one, the ready for agent, sorry, I guess there is still a human involved in triggering the agent, right? Like I guess I'm trying to understand the distinction as to when that would be like a straight shot.
It's like, this is a bug fix, or this is an obvious thing we wanted to do anyway, or like, there's no real, like, it's very clear what needs to be done.
Yeah.
Like a ready for human would be more like, just like if you were to throw an agent at it. I don't know. I guess that's, the agents are more and more capable. So I don't know where you draw the line and say that this needs a human, but it's maybe just that there's more wiggle room for how it might be interpreted.
I guess I'm questioning the ready for human one. Isn't that kind of what we already do by default? Like the agent one is the low-hanging fruit that is kind of like separate from the other one, but like ready for human is like pretty much most major features.
Sure. It could just be, I guess what you're saying is it could be ready. Or you could just have the lack of needs info.
Interesting.
Is that what you're saying?
No, that's not what I'm saying. I guess it's up to the maintainers who are most commonly using the badges or the labels. If anyone else has any thoughts.
I guess here's what I'm saying, Prashant. It's like, say you're filtering for issues and you're like, I'm a person that want to start an issue. How do I find the ones that are ready for me to take up?
Okay,
so I just
got it.
Doesn't have needs info and doesn't have ready for agent.
Can we just say, call the label, sure, let's go.
Yeah, no, I think that makes sense. Yeah, having 3 separate badges makes it easier to just filter on a click, and then you have everything visible. Yeah.
How about
Sorry, that was garbage.
Yeah, you cut out.
How about ready to implement?
Ready to implement. There we go.
And the distinction there is. You repeat that again, Will? What was the distinction for this one?
It's like we have triaged this. It does not need info. Okay. So it's like if it has nothing, then maybe no one's looked at it. if it has needs info, someone's looked at it and is like, I don't know if we want this. And if it has ready to implement it, that means someone's looked at it and is like, yeah, this is definitely something we want.
Cool.
Cool.
That sounds good to me. All
right. We can go to this one.
Yeah. I just wanted to highlight, I think we had a proposal, and I think people are generally supportive of the idea for a while of like transitioning the transaction info away from these sort of like operations that are specific to different operations and more towards something more generic, like actions that you apply to a manifest. So I've pulled out or like split up a bunch of issues into a project, and I'll start working on them in like a couple weeks. And once I have sort of the initial first one done, then I'll probably invite more people to help out with the remainder of them. Yeah, I just wanted to highlight that I think we'll start that soon, because I think I've been wanting to do that for a while.
Yeah, I think it really helps to understand, like, here's the actions and here's the conflict matrix.
Yeah. And I think that that's part of like the most uncertain part is I'm not 100% certain how much it'll simplify the conflict resolution. I'm hoping it will.
I think the thing I saw when, like, the biggest issue I saw, because I went through and I documented all of like our current conflict resolution behavior. And one is like, it was not obvious, like merge is just sort of an evil transaction that or operation that should never be used. And I think we've been moving away from it for everything. But I had to think of why, and it's like the reason why is because it modifies the schema, and so it's like being able to yeah, I think it will make it, I don't know if it will simplify the matrix as make it more obvious, perhaps. So like add fields, drop fields, update schema metadata, all become very high conflict actions. It's still like, there's this weird thing, like if you wanted to add a column, it's much cheaper to, or like if you have this big system and you want to do a bunch of like adding columns to it, it's much better to do add column first, which is the schema only change, sets the column to null, and then do data replacement to fill it in, compared with, we had all these old approaches that would use merge to do it, where merge is like, we can change the schema and we can change the data files. But anything that changes the schema conflicts with anything else that changes the schema, or really conflicts with anything else at all. Because if you're changing the schema, then an append operation suddenly conflicts because you wouldn't create the right data files. So it's like, that turns your whole operation into this very high conflict thing. Whereas if you do the add first and then you do the data replacement, it's not so high conflict. And it's like, I don't think this new model changes that at all, but it might make something like that more obvious. I don't know.
That makes sense, yeah. I'm hopeful that's it. I think my main concern is whether or not like the semantic meaning of append versus delete is important or not, as separated from the actual just like actions you're applying to the manifest. But we'll find out. Jono, I'm not sure I understand your question about operating without depending on Lance.
Yeah, my question is that I'm seeking for a way for users for them to operate on Lance fragment and Lance index files directly from storage without even depending on Lance. For example, if they have a proto files and they can understand the transactions directly, maybe this could unlock many different other use cases.
I mean, you could always write a different implementation of like a Lance reader or writer that's not the Lance library. but I think that's always possible, regardless of whether or not this feature is implemented. I'm not sure if it makes it any easier.
Okay.
I mean, Dan and I had a little discussion yesterday about indexes, and like there's this sort of question in Java, they want to access the zone map index data itself. And so it's like, what does that look like? Because currently we haven't had any APIs to just expose indexes themselves as like arrow objects or anything like that. And it's like, we want to move to this model as indexes as plugins, but it's like the indexes are just in storage. There's nothing stopping anyone today from going and reading those files and doing whatever they want with them. So like if you wanted to make a zone map index plugin, it could just ask Lance, hey, where's this index located? Get the file locations and then do all of that itself without involving Lance whatsoever. It's like, oh, here's the zones and give you all the information. I think Lance only needs to be involved when you're doing like the modifications, really. And by Lance, in this case, I mean like the protocol, the format.
Mm-hmm. Yeah.
But like even today, read only, there's nothing stopping anyone from reading the data there with a completely non-Lance tool in any way they want to.
Okay, got it.
Anything more on this, or we can move to the next one?
I don't think so.
Okay.
Just
table row ID. Yeah.
Yeah. One thing I've noticed is we've gotten a lot more bug reports on that related to stable row ID. And I think maybe people are picking it up a lot more, but I'm not sure like how stable and well tested that feature is. Yeah, like I don't know. So some of them are correctness bugs, I think, not just performance bugs. It's a lot of performance bugs. I'm wondering if we should like maybe have some disclaimer now that it's experimental, but then provide a roadmap for like better testing it and stabilizing it. I think it's partially implemented, but I think it's not clear that it's performant.
Yeah. Okay, go ahead.
Oh, you can finish.
Okay, I have a quick question around table row ID. In my understanding, this feature is introduced by ByteDance, right? And are they really using them in production environment?
Yeah, I guess I can answer that. Yes, they are using that, and it's mainly for I think two cases. The first one is they have like a UI and you can edit a specific row, and by using stable row ID, that row stays in the same page even after you edit the row. So that is one of their use cases. And another one is the change data feed. So there are some they added those features. I don't know if they are actually using that in production. So that's still pending confirmation. Yeah, but those are the two big things they have been pushing in the stable row ID side of things.
Yeah, sorry, my comment there was a little glib, but stable row ID, I think the thing is like we at LanceDB don't use it. And so it's weird for us, but we kind of understand why it is needed and community is interested in it and wants to build on it. And so it's like, I'm a little bit worried about how do we make sure that happens. So like this PR here, I don't really see any problem with it. I was kind of reviewing it. I'll review it a bit more and I'll put a review up. But it is a spec change, so it's going to need 3 PMCs to get it moving forward. So like, how do we move forward these experimental things? We need to highlight because yes, I guess that's just a general concern. And it's like, is experimental the right term if others are using this and consider it not experimental? I don't know. So.
Yeah, that's a good point. I think actually I was kind of cheating a little bit when I was doing the mem table, and I just marked that as experimental, and then I merged the PR. Maybe actually that might be a good model that we formalize the concept of experimental spec changes, and those don't have to go through a vote because those are still under iterations. And when the feature is relatively confident, at least from the spec level, and there are some usage proving that it is fully working, we can have a vote, actual spec vote to remove that flag. That seems to be pretty desirable to both move fast and also have a formal process around it.
I guess how I've seen it work in other projects with like experimental features that are merged into main is that we still vote on it, but we just sort of use the experimental label to address worries that we're not sure about this API, 100% sure about this API yet, and sort of get more 1+1 votes. But still have the votes in the meantime.
I mean, I like the idea of an experimental tag, and then maybe it's just has a different criteria of one PMC vote or something like that.
Yeah, I guess it could be all right. Yeah.
The tag allows you to be. Sorry, go ahead. I was just saying that the tag allows you to be a little bit more flexible with like backwards compatibility or breaking changes, et cetera, et cetera. I think if something's tagged experimental, it seems like you're not tied to any solution, right?
Yeah, I think that's yeah, that's like the key meaning of the experimental flag. But also, yeah.
The classic flaw of such a flag is that something stays experimental too long and people start to rely on it, and then they get cranky. But that's I think it's better than I think the alternative is, especially for this, like, I mean, we have a community, which is nice, but I think still a lot of the work is being done by a core group of people. And so having the experimental label is a way for people to move forward on features that aren't a priority to the core group.
Mm-hmm.
Yeah, I mean, part of why I brought this up is that I also just want to make sure that if people are running into lots of bugs related to this feature, that they kind of come to it with understanding of like, oh, like I was using an experimental feature and this is why it doesn't perform well. Because I want to make sure that it's, if they're seeing this feature and they're finding it not performant or buggy, that it's not reflecting that in the project. That's my main concern. And it's also just not having people, people want to write very big data sets with Lance. I don't want them to be like, hey, I wrote this very big data set in production and you broke my 2 terabyte data set.
And I guess going back to the stable row ID roadmap, I think outside of the 2 that I talked about that ByteDance has been pushing for, I think the very original discussion around that ended with we want to do some benchmarking around the performance impact because we know it will add a translation layer between stable row ID and row address, and we don't know really how much impact that is to the whole search path. And that essentially has been a pending item that hasn't been done since the very original discussion. So I think that would be a good starting point to have that data point so that we know, like at least people have an idea that if I use stable row ID, if the index is indexed by stable row ID, then does it actually have a performance impact? And if so, how much from the memory usage and also just in general performance perspective? Yeah.
Yeah. And my thinking with the roadmap is like, if we can at least say like, hey, this is experimental, and like, hey, these are the things that we need to test and validate and fix before we like call it stable, then that it might invite some contributors to work on that. And then it also will also just show in a very visible way, like, hey, this is why it's experimental, and these are the gaps that need to be closed before it isn't. If people care about those gaps, then they might think twice. I'm willing to sort of like write up some of those issues and make that milestone so that it's clear like where those gaps are. But I don't think I want to necessarily work on those.
Shonwo, did you want to clarify your question, or has it been answered?
Yeah, my question is a bit weird because I'm thinking maybe it's a time for us to revisit the whole thing. Like, is there other way to design this feature, and is there a deeper problem for us to address? I mean, before we trying to make this thing stable. From my current understanding, this feature seems to be interacting many part of Lance, and our whole system might become two part of code. One is we don't have stable ID, and the other one is that if we have stable ID, we need to do this way. So I'm thinking, can we make a better thing, like for example, we can always have stable IDs, and we can just make everything works faster as like before, or it's too late for us to do such thing.
It might not be too late. I think it's more, yeah, we're not sure if we want to invest that effort yet.
Right, I think that goes back to we essentially need the initial benchmarking to get the data. I think we have all the code ready to do that, but we just never have any time to do that for any of us. Yeah. And by the way, I think we are using stable ID in some cases, like the materialized view refresh is based on stable ID. Yeah.
Okay, I don't have other questions, and we can move to the next item.
Yep. Yeah, if there's any more follow-up on that, I'm guessing we can continue that discussion on GitHub. Okay, Jack, I think you had this one.
Okay, yeah, this is more of a brainstorming regarding the recent index segment feature we have been doing. And one of the questions I think I hear once we are talking about this architecture to some customers is that then can I start to, because with this architecture, essentially when you do a vector search, you will search inside every segment. And that naturally raises the question about, can I do some initial pruning about the segments, which means the index segments could potentially be aligned with the layout of the table. And currently we are just aligning based on the fragments, but the fragments can essentially mean anything. It's kind of naturally loosely partitioned by the right time, I guess. But I think if we look into other systems like vector databases that are out there, then essentially it's moving into a very similar concept of almost like a partition concept, that you could also say that instead of doing this kind of naturally based on the fragments, we can we can start to almost like partition the fragment in some way, and then that can reduce the vector search computation because we can prune the segments to search based on the partition value, and then only search certain segments. So I don't know what is our general direction on this. Do we, for example, if we do liquid clustering, would that be usable in this sense, or like, yeah, what is just our general thoughts on this?
Yeah, I implemented something like we can just search fragments that covered by a single index segment. Will this address your this feature request, or they are different things?
And I didn't quite understand what you said, Junwo. Could you say that again?
Oh, okay, sorry. I added a new API in our search that we can specify index segment ID. Say I want to search this index segment, and I will just search the fragments that are covered by this segment, and I make sure that all other fragments are pruned, and I will never touch them.
Yeah, but I guess, so can you use that API? Say like you have a filter, you know, like country is like Canada, and then that gives me a pre-filter mask, and then I can derive the fragment IDs that correspond to that, and then I can use that sort of in combination with that API to prune which index segments I search.
Yeah.
Is that the idea, or is
Mm,
that?
I don't think you can, because first, is that the problem you were describing, Jack, is where the user does have some kind of meaningful partition key and they want their search segments to align on that partition key so that they don't have to search as much?
Yeah, kind of. Yeah.
Because like what we have now, what Sean's been working on, allows you to partition the vector search space, but it does it in a way where you still have to search all of the partitions every search. You can just do that in parallel or even distributed. I think what Jack is proposing is a way to partition the vector search space so that at search time, if that filter is present, you don't have to search every segment because you know which segment you would want to search. And I don't think the stuff that Shuang was building prevents that necessarily, but it doesn't enable that really, because you would need some kind of physical partitioning feature which made sure that the fragments, these fragments had tenet 777 and these fragments had tenet 800 and so on.
Yeah. My idea is that we can do something while we are building this index. For example, we can partition those fragments at the right time. We can start those 100 fragments between partition 1, and we can combine them together into a single index segment, so that we can just say every segment can map to a partition. So we can use this index segments ID as partition ID, as we mentioned before.
Yeah, so I guess my question is like, yeah, couldn't you just basically get this with clustering and a pre-filter that masks which fragments you're searching, and therefore narrows down the segments?
Yeah, that's actually what I'm thinking about, because when I wrote this, I have no idea what I'm thinking about, to be honest. And I think if we do clustering, does that solve the problem? I think the key seems to be that, suppose today I have like 100 fragments, and those are clustered, and they have, like, let's say 3 segments on those 100 fragments. and then I write or somehow updated the data to have all these 20 more fragments. And the current way we do is that just we build a new segment, right? We will likely build a new segment on those new fragments. But does it actually make sense that actually we will, for example, we do a clustering compaction that we merge the fragments into the existing ones, and then we rebuild the existing fragments so that they kind of keeps in the rough layout that is useful for pruning, and and it doesn't just have a new segment that kind of just have all the data mixed together. Feels like there's a potential path to do that.
So I think that this would be like really contingent on how we define like the clustering algorithm, right? Like the traditional liquid clustering in Delta, basically like once fragments are clustered, they don't get reclustered, right? And so the idea is that like these Z cubes, you would, you know, if you have 10 unclustered fragments or 20 unclustered fragments, that you would cluster those all together, you know, order data within them and then write them out as individual fragments. So I don't think, you know, you would have existing segments that would be changing frequently because of the clustering algorithm. It would be like new data, if I'm understanding correctly, right?
Well, so you could, let's say that we said the Z cube is 10 fragments, and then we wanted 10 segments. You could maybe do it that way, where like segment 1 is the first fragment in each Z cube, and segment 2 is the second fragment in each Z cube. Be a little bit of a different way of building your index, where like today it's like every new fragment we sort of SP fresh it into the active index, it gets big, we seal it off. So we'd have like 10 active indexes in this case, and we would keep building them and sealing them off. But it seems like there is a way you could design
Yeah,
something
exactly.
like that.
Yeah, but I do think Danny make a good point. Like it's not clear like what is the scale of the split of like how of separating data, because like sometimes clustering could just be like, oh, like, well, I separate it within the file or within the fragment, but that's not necessarily what you want if you're just pruning at the segment level. I do wonder, like, because I think the other thing that you ought to evaluate, well, actually, I'm not 100% sure, but I do think the other thing we might want to evaluate here is like, do you want to bring what was I saying? Oh, like the partition key into the vector index itself, and would that be useful as an approach?
So if you had the clustering thing, then even if, let's say the vector index is completely unaware of the partition key, I think you could do like a quick index search to just tell you which fragments hit your particular filter. You know, like I don't know if all the scalar indexes could support an operation like that, but if they could, like you could very quickly determine, oh, I have 10 and ID equals 777. These are the 40 fragments that hit that, and then from there, just say, okay, well now which segments do I need to search? And it all just kind of happened naturally, even if the index itself was completely unaware of the idea of any partitioning.
Yeah. I think that's how I was imagining it entirely before. I was more thinking like, I feel like the segment pruning thing helps you as soon as you get to a point where you are at a scale where you want to have many segments. But I feel like there's also maybe like a pruning advantage, maybe even when you're at a smaller scale where like you don't have multiple segments and you want to be able to like, or you just have a few, you know, maybe only have 2 or 3, but like you can't, your data just doesn't happen to be laid out in a way where it makes sense to prune entire segments. And that could partly be because maybe doesn't make sense from like a write application standpoint to like be like, oh, I want to recluster, so I have to rewrite all of my fragments and all of my index segments. That's a lot of data to rewrite. But baking in the partition key into your index might make more sense. And that could lead to maybe better pruning. I'm not sure.
I think it might help to have a concrete use case.
Yeah, I think like having more concrete use cases and exploring more solutions would be good. I think especially like having a concrete use case that says here's like what is the data, and like think of it at different scales too.
Yeah, like maybe multi-tenancy is probably a good enough one. You just kind of flesh that out a little bit and think about what does multi-tenancy look at different scales. Because I think, I mean, the small scales, does it really matter that we're searching more data? Like, this is like, are we trying to make a 10 million search into like the microseconds instead of the milliseconds here? Are we trying to make like a 1 billion search feasible? Like, which problem we're trying to solve there is where it matters, I think.
Okay, I will raise a discussion in the GitHub discussion about this.
Great. Yeah, I'd like to dedicate like 5 or 10 minutes to address the iceberg PR as well. I know we have Manoj, who's a community member who raised that PR on this call. Actually, Manoj, you raised a lot of comments on the Discord as well. Now that we have some relevant team members here, yeah, this is on the iceberg repo, I believe, or your fork of it. But yeah, was there anything specific that you wanted to discuss with the team? The JNI gaps specifically. Oh, you're on mute.
Thanks.
Yeah.
Hi everyone. Yeah, thanks for your contributions and innovations, constant innovations. So yeah, I was experimenting on the iceberg integration, especially the file format API, and like I was looking into these things. Like my goal was to actually have some kind of feature generation done in isolation, and then I mean, like have them joined using iceberg itself, like without having a Lance table format. However, like I thought like I couldn't do that. So my first question would be, with the file format API, the iceberg has got into, we cannot have fragments supported there, which is like native to the LanceDB itself, right? So I was just trying on some workarounds on to have some kind of fragment support, but that would just like be a hacky messy workaround on the iceberg table format. So yeah, that's one thing which I would really love if like, I mean, like I can directly use LanceDB, but just the catalogs and all these things need to support, and that's where it gets like the wait time increases. And however, these are just the limitations which I found, but like I haven't completely dwelled into that. And thanks, John, for your time and addressing some of that. And yeah, if I get time, I will be continuing to work on that. And yeah, I think I'm done.
So just to summarize your question again, the main one you have is,
so how can we leverage the fragments is such a powerful feature when it comes to generating features in isolation, and whether we want to batch join them or even look up them. So if I'm just writing them to iceberg tables, let's say I have like 3 iceberg tables, everything is following a Lance file format, and we have we want to join these features at some point of time. how would I do that? This is like in Lance table format itself, I can leverage the concept of fragments, and on the same table, I can land different features as a fragment as a unit by itself. However, when it comes to Iceberg, the story gets different. It's more useful on Iceberg when it comes to random search, in my opinion, or like random access. So yeah, and other thing would be like, let's say if we have a clustered fragment, in the sense like I have an entity for which I'm kind of building features for, and I have one table, a logical group. I want to organize them into logical groups, not just like I have this entity and all the features for this particular entity will be like dumped into this particular table. Instead of that, if I want to organize the tables into logical groups of fragments, and if you have two such tables or three such tables, how would I join them? With the order of the row ID would be the same. Would it be guaranteed in all the three tables? So this is another question. So that, yeah.
So for the first question, the one proposal I've seen, or that was described to me, was that you could say a file, like if you wanted to make a Lance table readable by Iceberg, you have this problem where that Iceberg expects a list of files, and those files are complete rows. Whereas Lance, we have two layers. So one proposal I saw was like, okay, what Iceberg would see as files would just be like dataset URI hashmark fragment ID. And then when you read that file, the file reader wouldn't actually just be reading a single file, it would be reading the dataset for that fragment. And so then the file reader would be responsible for going out and fetching which files are needed for the given field IDs that are for the projection, and actually doing the read. So that's all I've got. I think I understand the problem, and I've seen it as a potential solution. The second thing you're describing, I think, are you saying that you have 2 or 3 tables that all have the same number of rows but different columns, and you want to turn it into one wide table with all of the columns?
Yeah, essentially pivoting them when needed based on some kind of a use case. Let's say for some use case, I just want to pivot them or pivot only on the 2 tables or the columns present in the 2 tables, and for another use case, I just want to pivot it on all the 3 tables. Something like that.
You could do it in theory as a metadata only operation, I think, if you made your super table, did a whole bunch of add columns to add all of the columns, and then used data replacement plus multiple bases to fill in all of the data files. I don't think anyone's ever actually done that, so there could be plenty of pitfalls that you would run into, but it's an interesting thought.
Okay. However, like, yeah, another interesting question would be like when it comes to joining such tables, it's yeah, LanceDB is more like a file format and a table format, but it's not on the execution layer, right? The join is done by engines like Spark or Ray or Trino. So how would these layers leverage the metadata present on the or given by the table format itself, like the grouping they are in, or like the sort orders and these kind of things, in order to like make the join quicker, or like should it use some kind of a shuffle hash join, or I mean, so there
are
are
the
these
rows in different order, or are they like, are you saying you're just zipping the the rows together, or are you saying you would actually need to join? Like they have
Yeah,
the
I
same
mean,
number of rows, but on different order.
yeah, so basically, it's a classic data engineering problem, whether we want to lay out a particular table with a determined sort order or not. Based on it depends on the use cases, how we are using the table. The downstream users sometimes would be beneficial if the table itself is not sorted. And sometimes it would be beneficial if it is actually sorted, so that some kind of joins would be like faster. So it totally depends on how the downstream use cases are. And based on that, yeah, the problem would be this data, the metadata present on the file itself, if that can be respected by the execution engines and deal with it, would be much more beneficial. But yeah, that's just a brainstorming. I haven't like delved into the whole details of like how Spark connector or the data source V2 connector does it currently, or how it happened.
If the data is not sorted, I don't think you need anything special. Like Spark to join those tables, it's just going to do a full table scan of each of the tables. So as long as you can do a table scan, you're fine. If the data, if the data is sorted, then Spark could do some kind of merge, sort preserving merge or something like that to join instead of doing or merge join instead of doing the hash join. Now we don't have clustering in Lance yet. Once we do have clustering in Lance, then that will tell you what the table is sorted by, and should also add the ability to do like a sorted scan. I think those would be the features that are missing if you wanted to enable some kind of merge join in Spark.
Yeah, I have recently gone through some merge into problems with the Iceberg. So I've solved it using storage partition joins and shuffle hash join. So something which usually takes around like 60 minutes, it's now done within 4 minutes. So that's the kind of optimization which is happening if the metadata is being respected by the execution engines. So.
Yeah, I think once we get clustering, we want to enable those features. Like clustering is how we want to implement storage partition join, I think.
Yeah, makes sense. Thank you.
Yeah, and to be very clear on that, right now there is an active PR in the Spark connector on Lance right here that will implement Spark side for once clustering is enabled to do storage partition joins effectively. We just need to build, the underlying clustering framework as well.
Jack, do you have a question or comment?
Oh, I just have an idea about the very original question about how we integrate fragment, because I think I originally proposed the idea of we can kind of hack the.
Yeah.
I don't know if it's hack, but like using the URI plus hash fragment ID. But I'm not thinking actually, why not go? I don't know if it's crazy or not, but why not go even one layer above? Like, if we just treat the Lance table as a file itself, because we have been trying to do the column stats thing, and let's suppose we have done that. Then at that point, what's really the difference of a table and a file from the sense of Iceberg? There's not really much, right? It's just a directory named some file.lance versus a file for some file.lance. But then in the end, it calls the exactly the same API because you can write data into that, you can read data out of that or in arrow batches, and then you can get statistics out of that container, right? So if that is easier to integrate, why not just do that? I'm just thinking out loud here.
Yeah, Jack. So I was also thinking the same stuff. Like, why can't it can just directly operate on the format itself? And the problem would be like when it comes to the maintenance operations, like deleting the orphan files, it doesn't know what, it just deletes that metadata file itself, but it doesn't forward to the other layers.
But that's fine, right? Because you are like,
Yeah.
because there are always two steps, right? You first expire the snapshots, and that marks whatever file that is not linked as orphan, and then you just the remove orphan is like you remove all the files that are kind of not in your parent tree, right? And whether that file is a directory or that file is actually a file, I don't think that really matters, does it?
But theoretically, I feel like it works, and it's just like I felt like it could be crazy, like.
Yeah, but just an idea I think I like to share, and maybe it actually would work well. Like just have Iceberg as yet an outer layer wrapping multiple Lance datasets. Yeah.
Cool. I think I'm done, Prashant. Thanks for facilitating this.
Oh, absolutely. Yeah. I mean, there's always async discussions that can go on Discord or on GitHub. So, quick question about this PR. I know you said it's not requesting a merge on the Iceberg side, but your goal is basically to try out some of these ideas and I guess test it out more and potentially try to. Yeah. Okay. So I guess, yeah, once you make progress, you can feel free to ping the team on either Discord or GitHub.
Yeah, sure. Thank you all.
Yeah.
Oh,
I
thank
think
you.
we're at the hour as well. Yeah. Thanks a lot for joining. I think we covered our agenda for today. So if that's it, we're on the hour right now. And yeah, thanks everyone for all the inputs. We'll be in touch on Discord.